All right, good afternoon, everybody. I'm Curt Barnard, and yeah, I'm presenting on Who Watches the Watchers and Understanding the Internet's Background Noise. So real quick, just to tell you a little bit about myself, I'm Curt. I started a company and moved onto a sailboat full time. I'm a one-handed sailor. People think of living on a boat looks a little bit like something on the left, but it's a little bit more like something on the right. People like to call it fixing your boat in exotic locations, and it feels that way sometimes. I often refer to my boat as my mobile offshore computer network exploitation platform. I like to tell people I seek international waters to cover my bases. But to tell you about what we're going to talk about today, I'm going to talk about internet mapping or internet cartography. I'm going to start out with that and kind of go into detail about mapping in general and mapping of the internet. I'm going to talk about some neat TCP IP stuff. Maybe it's neat, I don't know. And I'm going to talk about mapping tools, technologies, and websites and actors and who's doing it and why. And I'm going to go into talking about the background noise of the internet. Then I'm going to demo a tool that lets you listen to the internet background noise. There's going to be a QR code at some point so you can actually go to the link. So get ready for that. But yeah, so I'm going to talk about internet cartography and the fact that people love internet maps for some reason. That doesn't make a whole lot of sense to me. And we're going to talk about why that does or doesn't make sense. But to get started, I want to talk about like regular maps for a minute. This is like the standard world map from the CIA fact book. It's primarily like geopolitical, so you know where the countries are. There's some high level topology of the oceans and mountain peaks and things like that. But I want to spend a little bit of time talking about like why people make maps and for what purpose and like what questions that they answer. So some of the earliest maps looked a little bit like this. So on the left, it's a celestial map from 1670. So primarily these were used for navigation. It was the first really form of navigation with celestial navigation. And to make inferences about the changing of the seasons, it was kind of the best way to do that. This map doesn't look like our star maps today because there's like lizards on it because that's what made sense for the people back then. And on the right, this is a map of the known world in 1482. They thought it was very important to have people blowing at the corners of their maps, so they included those in their maps. Maybe you would not see that today, but this was kind of, it existed in a place and time, and this was the known world. And also, of course, you notice that there's a huge missing chunk of the planet, which got bumped into later, which is where we are today. So if you were planning a trip to old Las Vegas and you wanted to kind of decide where you were going to go or what you were going to see, you might actually use a map like this that kind of shows you like what the attractions are of old downtown Vegas. You probably wouldn't use this to actually navigate unless you're one of those psychos that uses landmark navigation, in which case you would use this map. But really it's just to give you a rough idea of like scale and relationship of features that exist. There is a crossroad that you can see as kind of like an anchor point. But this is something that you would use to maybe figure out like what you want to do and see when you come to Vegas, but you probably wouldn't use this map to figure out how to get there. You all probably use something like this to figure out how to get there, which is what we use to figure out how to get to the hotel. And this is what everybody uses day to day, but this is primarily for navigation purposes, although there's a lot of sort of landmark finding in this now. But I actually want to take a little bit of time and talk about the maps and navigation aids that you use when you're sailing. And so hopefully some of this is new to you, but I think it's a little interesting to make some comparisons to internet mapping technology. So I want to talk about nautical charts for a moment. So nautical charts contain aids to navigation and hazards to navigation. There's a really interesting thing that I learned when I started sailing, which is that the bottom of bodies of water are not static. In fact, it's quite the opposite. They're moving and shifting all the time. And so in order to actually get this data, either NOAA or the Coast Guard, kind of depending on where you're at, will actually go out and they'll do sonar soundings of the floor, and they'll kind of paint the ocean floor, and they'll create these maps that have these contour lines. But they have to be updated kind of all the time. So for example, when we were down going through Florida, due to the recent hurricanes that went through Florida, all the maps were wrong and everything was totally different. And if your boat goes 6 feet underwater like ours do, you can run aground if you're not careful. That's not good. So you have to pay very close attention, and they actually have to send boats out to do soundings of the ocean floor to update these maps. And if you're using paper maps, you have to buy the new ones. It's kind of a pain. But one thing that you might see on here are these red and green, and there's some yellow and black markers on here. These are called aids to navigation, and they are buoys that mark generally where they dredge and what the safe parts of the water are to travel through. And so this kind of brings us to our second aid is the buoy. So the buoys actually have to get updated like kind of regularly. So the Coast Guard will go drag buoys around to mark moving shoals. And so really you have to use the nautical charts to tell you roughly where you're going to go and what buoys to look at. And then you have buoys that get moved around on a weekly or monthly basis based on shifting shoals. But those are what you actually need to pay attention to. That's what's going to tell you if you're going to hit the ground or not. And then in a totally different vein, you have these things called piloting charts, which are managed by NGA that show trends in oceanographic weather over time. And so what you're actually looking at here, the little blue kind of weather vane looking things show the prevailing winds and how often they are out of which direction, and how strong they are and how many days are calm. On average over a 30-day period. So I think this is for the month of September. And so every single month there's a different chart, a different piloting chart that's going to show you kind of what the general conditions are going to be like. So a chart like this you're going to use to say if it's the month of September and I want to go from Charleston to Miami, what kind of conditions can I expect? It also shows wave heights, but these are over long periods of time. These are like averages over like 30 years. These don't really get updated very much, and when they do, it's kind of minute changes. It's not really strong changes, but these are updated pretty infrequently. Oh my gosh, what happened? Yeah, so the NGA actually owns these charts. And then you have maps that come out, or weather forecasts that come out of the National Hurricane Center. So this is Hurricane Hector, which is pretty relevant today. But this is going to inform folks that are making like national level policy and planning disaster relief and organizing FEMA and saying, hey, what do we do to help the people that are going to be in the path of this hurricane? And yeah, you might use it to figure out that you're not going to have a picnic on Friday, but that's not the primary purpose of something like this. And then you have pretty standard weather maps. So this is what you use when you sail, but you might go to weather.com or weather.gov. But this is showing the prevailing winds. That's going to give you the current, up-to-the-date information on what the winds are doing and if there's rain, like right now. So it answers questions like, am I going to need a jacket or an umbrella? Is it windy enough to go sailing? Things like that. So I don't want to pick on the Department of Homeland Security because they have a very, very hard job. But I do want to talk about some of the things they've done and some of them that I think are kind of funny. So there's this piece of legislation that came out in 2015 called the Cybersecurity Information Sharing Act. And it kind of spurred this conversation at the Department of Homeland Security and kind of spawned this conversation on what they call a cyber weather map. And their goal was kind of to have the types of maps that I just showed you that apply to cyberspace at like a national level. And it's the DHS is like in a really tough position because they have a very hard problem to like defend like cyberspace like of the United States on like a national level. So I'm giving them a little bit of slack here, but at least in their defense, they came up with some very specific questions that they hoped the cyber weather map would answer, such as, are we, I don't know who we is, are we under attack? Who is attacking? I also don't really know what that means in this context. What are the consequences? That's pretty good. And what are the next targets? I think that's a little optimistic, but and then I want to quote the former Deputy Secretary for Cybersecurity. I put this quote in Comic Sans on purpose. And this was outcome of CISA, where she says things like, in English it means that the threat indicators that show you what might be good and bad in cyber, and away with all the privacy, civil liberties, expertise, collect them in one place. I'll let you read the rest of it. I won't read it to you. But these are kind of the quotes that we have unfortunately come to expect out of the policymakers in cybersecurity. What actually came out of that, I'm going to show you a slide from her presentation at the RSA conference in 2016, where she kind of showed what she thought that looked like. And it's a slide that kind of looks like this, which I think all of us have probably seen something that sort of looks like this. There's a bunch of dots and they're all red and they're all geolocated, and I have no idea what they mean. So there's a word cloud down here that says DNS, so that's, I guess, neat. But I don't know how many dashboards that I have looked at that look like this. And if you remember those 4 questions that they said that they thought they were answering, I don't know which one of these gets answered by, is answered, but for me it's 0. But what this actually looks like, honestly, is a little bit more of like a hurricane center map than like a weather map that like the average person is going to want to pay attention to. They might say, hey, we have X number of vulnerable IoT devices. We might need to, at a national level, prepare for something, right, that's going to come out of some sort of IoT attack. But certainly I wouldn't expect my mother to look at this map and decide that like, oh, I need to be really careful about phishing today. And I'm not really sure that there's a map like that that exists, like for the average, like normal, like consumer of computing technology. I will say valiant effort, but I personally don't really get it. But a big thing that I've always questioned when I see maps like this is how useful the actual geolocation data is. And so I have a saying that I like to throw around. If you guys have heard like the cloud is just someone else's computer, if you've heard that before, I like to say geo IP data is pretty much just MaxMind or Newstar. So like the 2 people that provide these data sets, and everybody just like compares the 2. So really the geo IP stuff is just straight out of these 2 data sets like 99% of the time. So I want to talk for a minute about cool IPv4 stuff, and this is cool if you're into like governance and stuff. So I'm going to talk about ICANN for a minute, which is a really sexy topic for B-sides. But I just want to talk about a little bit about like IPv4 like a really high level, and how like high level organizations like conceptualize IPv4. So you guys know, or probably have heard of ICANN, which like ostensibly is like the governing body for the internet. Like that's probably what you've heard about it, which was kind of like internationalized in like, I guess like 2015 or something like that. Control was kind of taken away from the United States, and it was a multi-organizational organization, I guess, but pretty much they're responsible for DNS, IP address allocation, and like name disputes. They're the ones that get to decide whether .sucks can be a valid TLD or not. And they decided that it can, I guess. Then IANA, if you've heard of IANA, this is the OG responsible authority for delegating IPv4 addresses and IPv4 networks. They actually predated ICANN, but have now been reorged under ICANN, but they still do the same thing, I guess. So they're responsible for internet numbers and DNS management, except they delegate it further to the regional internet registries that are responsible for dishing these out to organizations within their areas of responsibility, which look strikingly like, oh, I'm losing my connection here. There we go. Which looks strikingly like the United States Department of Defense areas of responsibility for the Unified Combatant Commands. Not that they're related in any way, I just thought it was funny and we were talking about maps. And then they created this thing called the NRO, which is actually not the National Reconnaissance Agency, but the Numbers Resource Organization, which is tasked with protecting unallocated IPv4 addresses, being central input for the RIRs. It sounds like everybody's just kind of like punting to somebody else. And then they created this thing called the ASO, which provides input back into ICANN. So you have this weird like circle of pain that doesn't really make any sense to me. Maybe it makes more sense to somebody else, but they get to do things like have really sexy conferences about the WHOIS database. So that's pretty much what they do. And so just real quick, reports of IPv4 exhaustion have been greatly exaggerated. Greatly is kind of a misnomer, but this depends totally on who you ask, whether or not there are still IPv4 addresses. So when people say like we're out of IPv4 addresses, that means that all the like assignable network blocks have more or less been allocated, but like all these IP addresses are not like actively being used by computers right now. So there's a big difference. And actually, if you go to the RIPE NCC's website and look at their reports on IPv4 exhaustion, they actually have IP addresses still in the free pool in like a single /8. But what's kind of interesting here is if you look at the, it's supposed to be dark blue, but it looks black line at the top. These are reclaimed IPv4 addresses, and they do this interesting thing where they like kind of ask network owners to like return IPv4 addresses back to them, and they put them in this cool off period where they sit for like a full year before they can be used again, because they want to make sure that they're not actually being routed, because IPv4 routing is like way more democratized than people like to think. It's not like a fixed way that these packets get routed. So they put them like kind of in a timeout box for like a year to make sure that they're not getting routed anymore. But like you can still send packets like to those IP addresses and they'll still go somewhere. They'll just eventually like not get routed where you expected them to go. And then some like interesting statistics about how IP addresses are allocated. The United States has like a whopping like 34% of all existing IPv4 addresses, and that's only above the bogons, which are like non-routable IP addresses. So these are the 127s and the 10 dots of the world. So the United States is the only country that has more IP addresses than non-routable IP addresses that exist in IPv4 space, which I think is kind of funny. But since these IP addresses have been like unroutable for so long, you can't like make them routable. Like you can't like change the RFC and make them routable, because you'd like break everything that has been made ever since IPv4 existed. And right behind them is China, Japan, and the United Kingdom. But IP allocations like per capita, the Holy See comes in at a shocking #1 because they only have about 800 people. It's like a Catholic nation state basically. It's not the Vatican, but yeah, it's like 21. It's like 21 IP addresses like per person. So good on them. And then Scandinavia come in strong. So real quick, just to talk about like how many IP addresses there are. We talked about bogons real quick, but most of you know the 10 dots and the 172.16s to 172.31s and the 192.168s. I didn't, maybe I was just stupid, but I didn't know this back in the day, like all 127 prefixes go back to the localhost adapter. So I have a lot of fun like putting in my hosts file like a bunch of fake DNS names. So like when I'm testing stuff, instead of using like 8080 and then 8081 and 8082, I just bind it on like 127002 and 127003 instead, and it's like a little bit cleaner. But you can route all of those 127 addresses to your loopback interface, which is kind of cool. And 0.anything is just totally not routable. So what you end up with is actually a number of IP addresses that is a lot lower than 2 to the 32, which is like what most people say. So when you talk about scanning all IP addresses on the internet, you're not actually talking about 2 to the 32. You're talking about a number that's much less than that, but still very large. And there are also tons of like known IP blocks. And I mean, there's like a Wikipedia page about who owns all these /8s. Like you can go there today. The DoD owns like 10 for like no good reason. They just have a huge number of them and they don't use like any of them. But also there's some interesting stuff like AWS has large published net blocks that you can see. So if somebody was like, hey, I want to scan every node in EC2, you just go here, fetch all the CIDR blocks, and then you can scan them all and see what everybody's running in AWS EC2. And there's a really interesting component of that with AWS and the cloud providers in particular, because if you remember, I talked about how the RIRs use a 1-year cooldown period to make sure the IP addresses aren't getting routed anywhere else before they get reused. Not so when you're getting an IP address from AWS. There's no cool off period, and so as soon as you use that, you're getting kind of dead traffic that was intended for the host that came before you. And that's really interesting, and that's what we're going to talk about here in a minute. GCP, Google Cloud Platform, has the same thing, although it actually requires you to like run a NS lookup on a text record or something like that. So you all probably know the highest TCP port is 65535, which is not a power of 2. And that's because, of course, like 0 is counted. But I didn't know this before I started making this talk. You can actually use port 0. Like port 0 is a real valid TCP port. You can't connect to it using the bind function because the bind function like just makes it a random ephemeral port. But if you override the bind function, you can actually create sockets on port 0. I had no idea. I thought that was mind-blowing when I learned that. But the well-known ports are below 1024, so those are like static services that are established. And then of course everything up to 65535 are the ephemeral ports. But to do a TCP SYN and like see if a port is open and get a SYNACK back, it's going to take 40 bytes. That's what you'll need to send out of your network, and that's what will get returned to you is about 40 bytes. For UDP, it's the exact same thing, except UDP is smaller, so it's only 28 bytes. So I want to talk about the bandwidth required to scan IPv4. So I'm talking about a reduced IP space, like we talked about. We're getting rid of the bogons and unroutables and things like that. So just like from a bandwidth standpoint alone, if you wanted to scan for one port on all TCP IPv4 addresses that are routable, it's going to take 85 gigs of data transfer. And if you're using AWS EC2 pricing, it's going to cost you about 12 bucks. If you do 10 ports, it's about 850 gigabytes, and it's going to cost you 130 bucks. If you want to do all 1024 ports, it's going to cost you 12,000 bucks plus. UDP, one port, the very gratifying $7.99. I didn't make that up. It's actually $7.99 on the nose. So it's a little bit less for UDP because the size is so much smaller. And then if you were to scan, twice a week for a year, and store that in S3, this is what your cost would be. So it's actually really cheap to store, and S3 is really cheap. But for a year of scan data, twice a week, you end up at 1028 per month, which actually isn't too bad. So I'm going to talk about why we're not going to talk about IPv6. People exaggerate the size of IPv6, but only like barely to be like practical. So like theoretically it's 2 to the 128, which is that number there, which I have no idea how to pronounce. Not all the blocks have been allocated. So all IPv4 blocks have been allocated. So you used to be able to do firewall ingress filtering based on unallocated IPv4 blocks. But IANA advised to not do that back in 2012 because all those blocks have been assigned. You can still do that with the blocks that have been like reclaimed and are in the cool out period but not reassigned. But the number of blocks is so small it doesn't make sense. It's too much overhead. But with IPv6 you can do that because not all the IPv6 networks have been handed out. And you can tell which ones have been assigned and which ones haven't. IPv6 carriers also typically use this thing that is abbreviated SLAC. And basically what it means is a bunch of the bits in your IPv6 address are actually set to your MAC address by default. And so the only hosts that will be on your network have an actual valid MAC address. And the way that MAC addresses are designed, there's like fixed prefixes based on the vendors that make network cards. So you can actually drastically reduce the number of IP addresses that you'd have to scan for based on what the valid MAC address prefixes are because most people use SLAC. And so if you use some of these tricks, you can reduce the number of bits in a /48 subnet to 41. But that's actually still crazy. So going for a single /48, scanning a single /48 with mass scan, which says it does 10 million IPs per second, would take you 2.5 days. But there's like 2 to the 78 of these. And if you look at the cost here, the cost of scanning a /48 is like $11,000. So doing that 2 to the 78 times, it's just not going to happen. So there's some really interesting tricks that people have done to collect valid IPv6 addresses. I mean, you can scan for DNS quad A records that are going to have IPv6 addresses in it, although you're only going to find the IPv6 addresses that people want you to find. SHODAN did something really interesting and slightly controversial where they actually created a network time protocol server that they added to the default pool of NTP servers for a bunch of IoT devices. And IoT devices tend to use IPv6. And so they would actually reach out and try to get the time updated. And so they would collect IPv6 addresses from these IoT devices that were checking to get the current time. It was very clever, and they got banned kind of hard from the NTP pool because you're not supposed to do that. But it made for some interesting reads on the forums. There's a couple other things I want to talk about real quick. So this has to do mostly with passive OS fingerprinting. I don't know if you guys have heard of a tool called POF before, P0F, but it is a tool that lets you figure out what the operating system is of a host that's connecting to you based on network packet metadata. And I'm going to talk about two metadata fields that they use to do that. One of these is ephemeral port selection. So we talked about 1024. Ports under 1024 are kind of static, but ones above that, they're called ephemeral. Meaning they get used by the operating system on like outbound connections. But how those ephemeral ports actually get selected by the operating system depends on what the operating system is. So for example, FreeBSD, the ephemeral port range doesn't start until 10,000. On Microsoft Server 2003, it starts at 1024 and only goes to 5,000. So if you had a packet come in and the source port was 4999, you would know that it could be Microsoft Server 2003, but it could not be FreeBSD. And so using a number of different techniques that are kind of like this, you can figure out what the operating system is. So another example is going to be TTL, or time to live, which is the field that determines like how many hops a packet can take before it gets terminated by the router and doesn't get routed any further. And so TTL initial TTL selection is again different based on the operating system. So Solaris just went ham and made it 255, as big as it could possibly be. But some of them are, I mean, as low as like 30, which is pretty low, but actually in reality that's pretty sufficient for how many hops like most servers are away. And UDP on some of them is smaller. I don't really know why. The only thing I can imagine is that like if you're using UDP, you need it to be like kind of fast anyway. So you might as well just drop the TTL, because if it's more than 30 hops away, like you're kind of not really in a UDP situation anyway. But I don't know. That's kind of just a guess. Okay, so I'm going to talk about like who scans the internet and ostensibly why they do it. So I talked about Shodan a little bit. I don't know if you guys have heard of Shodan, probably, but they became really popular when they started showing that all these industrial control systems were connected to the internet. And basically they made a search engine where you could search for like HTTP headers and find all these machines that are connected to the internet. So they call themselves a search engine for internet connected devices. They primarily do port scans and banner grabs. They have an API and web interface. And if you look at their website, some of the things that are kind of interesting is they say that they're useful for market intelligence. So like if you wanted to know like if Argentina is replacing Cisco switches with Huawei switches or something, like that's kind of the play that they pitch there. So CENSYS was actually a project that was run out of the University of Michigan by the authors of ZMAP and ZGrab, and we'll talk about that just a little bit in a second. But they recently turned into a company that pretty much do the same type of thing as Shodan. They had some certificate metadata in there as well. But they used to be run from a site called scans.io, and it was all free. They still have a bunch of free data sets, but they now have like a paid API and stuff as well. Then there's this group called SHADOWSERVER. I don't know if you guys have heard of SHADOWSERVER. I don't know if people know SHADOWSERVER. But basically, I would have never heard of them if I wasn't like running reverse DNS lookups on stuff that I was seeing. But basically, they're a non-profit organization. They're kind of ideologically motivated, volunteer run. They do a ton of stuff, but one of the things they do is they scan IPv4 at like regular intervals. But they track botnets and run honeypots and do sinkholes and a bunch of stuff. But these are folks that will scan all of IPv4 space like all the time, just like Shodan and CENSYS. Rapid7 also has a project called Project SONAR. They're publicly available data sets. They do a lot of things like scanning IPv4, doing HTTPS grabs. They have some honeypot data sets and things like that, but you can go to their website and download these free open data sets as well. And then like there's these guys, USC, ISI, Ant Lab. Again, I would have never found them, but they have like RDNS queries, which kind of gives them away. But they're just a university research lab. They seem to have like grants from like DHS and NSF, but it's mostly for their like graduate like information studies program. But they primarily are just doing like ICMP. So just pinging all of IPv4, and they've been doing it since like 2003, which is kind of a while. And then the OG internet scanners are NetCraft, and they've been doing this since like 87 or something, and I had never heard of them until like running RDNS queries, so I would have never known. But they kind of pitch themselves as like cybercrime disruption, and they're this like kind of tiny shop in like Bath, England. And they've just like been doing this forever. They have like probably the biggest data set, although it's not exactly publicly available, but they give you like some graphs and dashboards and stuff. But they also do SSL surveys. They talk about providing services that tell you if companies are migrating their hosting providers. So like they'll say, hey, this guy used to be on like, I don't know, GoDaddy's hosting provider, and now they're on Squarespace or something. I don't know. But they talk about like migrating from provider to provider. And they say that they do due diligence for hosting investments and acquisitions, which feels really, really niche to me, but I guess they make money off of it, so good for them. So some other rad internet directories. So these are not like internet scanners necessarily, but there's this site called WHOISOLOGY where you can actually look up a domain name, and then it brings up all the metadata for that. So I did a lookup for BSidesLVegas.org. So of course Jack Daniels put his registration in there, and you can see the other kind of name squatted domains that were registered by this email address, but you can do it by phone number and like street address. And so people that are not very tech savvy that put in like their real home address and don't use private registrations, like you can find like all the websites that they've ever registered this way, which is kind of interesting. Nerdy Data pitches themselves as the source code scanner, or the source code search engine for the web. So in this case, I did a search for the CoinHive like Bitcoin miner that people are putting on their websites, and you can find like a list of sites that have this crypto miner on it that they've scanned. There's a really cool tool called WAPPALYZER that lets you identify different technologies that are running on a web property. It's a GPL v3 tool, so you don't actually have to use their website. You can like run it yourself, which is kind of cool. And then there's a site called Common Crawl, which they're a nonprofit organization that crawls all of IPv4, or not all of it's the Alexa top like 10 million or whatever, and they crawl all their websites and they put them in one place, basically saying we crawl the web so you don't have to, which I think is a great idea because everybody feels like they need to be the one that makes a crawler. So a really quick timeline of like some scanning technology and like history. So like I said, NetCraft's like kind of the OG in 87. So if you know somebody that was doing it before NetCraft, like tell me because I want to talk to him. And then Netcat, the Swiss Army knife of networking, was like 95. Nmap was in 97, featured in the Matrix, I might add, Nmap. And then ZenMap featured in the Bourne Identity. They have very good PR people, I guess. And then Shodan came around in like 2009. SHADOWSERVER, oh, that's out of order, got started in 2004. Then ZMap and ZGrab was in 2013 and 2015. And then MassScan was published in 2013, which had its own like network stack, which let it scan like 10 million IP addresses per second, which is enough to melt your own network, but not the network that you're scanning. And then CENSYS just kind of came out in 2015. Scans.io was out a little bit before that. Okay, so like there's a ton of internet background noise, and it's sort of just the cost of doing business, especially if you're running any infrastructure in a VPS provider. So like AWS, as soon as you kick off an instance, you're just getting slammed with network traffic, whether you actually see it or not. A lot of times it's on non-standard ports. With my company, we actually built a tool that like analyzes that background noise. So we just like listen for what all the background noise looks like in those VPS providers. And I wrote a tool that I collected some data on, and the data was super uninteresting because I was going to present it, and then it just like wasn't interesting, but I'll tell you about it. And I am going to open source it like right after this talk. So maybe you guys can help me make it interesting data. I don't know. But basically, I look to see who's scanning what ports on what VPS providers. And And real quick, just since we were like talking about port 0, so this is like a graph in Kibana of all the port scanning activity that's scanning for things on TCP port 0. There's actually, the source is like 50%, it's this like Russian IP address for some like Russian telecom, single IP address, which is kind of interesting to me. It's called Russia IT Deluxe, so that's cool. Yeah, so I wrote this custom sensor, and basically it's just like a little Flask app. It's like a little web server, and the intention was to try to feed a bunch of feed some data to people that were scanning HTTP servers to see if they would like crawl links, and if they would crawl links, were they going like depth first or breadth first? See if they would like execute JavaScript, and if they would execute JavaScript, I send them a Monero like Bitcoin miner to see if they'll crack some hashes for me. They won't, but I thought I would give it a try. Basically I was going to build this to try to characterize what different tools do. The other thing it does is whether or not, no matter what resource is requested, it always sends a 200 OK response, and it just sends OK as the words. And so there are a lot of tools that like will abort if the resource isn't there. So for example, if they're trying to like brute force your login script, if login.cgi returns 404, they're going to stop. But if you return 200, they might keep going, except that's not actually what I found. But in any case, so you can check this out. I just open sourced it. It should be public now. So if you want to contribute and like add some tests that might produce more interesting data than what I actually had, that'd be cool. Yeah, so this is just shows that data streaming again into Elasticsearch and Kibana. But it wasn't very interesting. So what I am going to show you though is the system that I use to generate this data. It live streams port scans back to a central location in real time. And I just set up this little interface that converts the destination port numbers into music. And kind of like just sends it to your browser. So I'm going to show that real fast, but you can check that QR code and it will come up. It doesn't work on iPhone, and I don't care. Oh, I'm not on the internet, so it's not going to work. But I'll bring it up. But that's all my slides, other than if anybody has questions. So I'll just bring it up while you guys ask questions, if you have any. Yeah.
There are some. Sorry, on my
Oh. Yeah.
Are there some active scanners, or all of them are passive?
Of the stuff that I set up?
No, not only yours. Like.
Oh well, I mean.
You give.
Yeah, I mean, all those folks that I went through and talked about, like SHODAN and CENSYS, they're all actively scanning so they have like a set of ports. I don't know if I'm answering your question, but they have like a list of ports. Like some of them are like 20 ports, and they'll scan them like every day or every week. And they will actually go out and run tools like mass scan to see what on IPv4 is like open.
Yeah. Okay. When I say, yeah. So I'm talking about the bot scanners, like they're trying different password stuff and all.
Yeah. So I don't run any of that. I mean, I see a ton of it. I mean, it's all the time. So just like by being in IPv4 space, like you're going to see whether it's on SSH or Telnet, but people will also just look for like WordPress login forms and like use default passwords. Yeah, that's all the time. And especially with IoT stuff, you can actually do some interesting correlations. So if like a new like Soho router vulnerability comes out, if you like follow that, like trailing by like 1 day, you'll start to see people scanning IPv4 just totally shotgun blasting for the vulnerable resources, and like the default usernames and passwords or whatever like authentication bypass there is. You can actually see that stuff all the time. I still see like shell shock stuff just like hitting all of IPv4 like even today. It's crazy. Oh, and this came up, and you probably can't hear it from here because audio's not on, but it's it's moving, that's audio. And so if you go to rock.threshingfloor.io and you don't have an iPhone, you can turn, this is the only time a presenter is going to tell you to turn on the audio on your cell phone for a talk. But if you go here, you can hear it. It sounds a little bit like distorted guitar music. It doesn't sound good, but...
If you unplug it from the...
Oh, from the HDMI?
The audio, yeah, and then you should be able to hold the mic over it.
Oh, I don't hear it still. Hold on. Am I muted? There you go. Yeah, right. Yeah, so you're listening to the background noise of the internet. So there it is. All right. So if they're nice. Yeah.
That's the back.
Yeah. Yeah.
You see a lot of that, and the reason I ask is if I send, keep saying, ICMP is port 0. So I have a feeling that there's port 0 traffic that I'm just not seeing engine by this classification.
Yeah, you know, so that's interesting. So there is ICMP. It's not actually port. It's called a code for ICMP. So there's a lot of ICMP traffic that's code 0. But you actually have to check to make sure that the protocol is set to TCP and not ICMP. I see like not a lot of it, but like non-zero, definitely. And it's the type of thing where exactly like you said, like a slight misconfiguration or even like an off by 1. Like if you say like 1 to 1024 and like your rules, you're going to miss port 0 altogether. And it's like an easy way for people to like slip in through human error to like get a connection that your firewall is not going to block.
And the only use to go out on port 0 is for reconnaissance. There's no other reason.
You can use port 0 just like you can use any other port. I mean, like I would say a legitimate reason to use port 0 is because you have a service that runs on port 0. But like why you would actually do that doesn't make any real sense because it's a non-ephemeral port that doesn't have an official designation and you have to write a custom like bind function in order to use it in the first place. So I would say like generally speaking, if I was a network administrator, I would probably block port 0 just like as a matter of course. And if somebody complained, I would ask them why they're complaining. Yeah. Yeah. All right. Yeah, that's it. I'll be around. I'm here for a few days, so you guys, I think saw my contact info, but I'm happy to answer more questions after one-on-one. So thanks very much.